So, you know what each of these terms is. H bar is the, it's a Planck's constant, right, and 2m is the mass of the particle. Psi is the wave function of whatever system you are studying, right, and then V, as we said, is the interaction potential, okay, or potential energy, depends on the system, right, whatever it is. And psi x, you have been using this term है ना, psi, इस वक्त we are writing just a one dimensional equation, so therefore psi is a function of x, ठीक है ना. So if we are able to determine the wave function, we can define the properties of the system. This system can be anything. It can be a particle, it can be an experiment, it can be a particle defined under certain boundary conditions and so on. We are not going into too much detail, we are just using this a little bit. So, for example, the probability to find the particle So, how will we find this? We will find this using the concept of the wave packet between x and x plus dx, and this will be given by the probability is equal to the conjugate of this function multiplied by the wave function. So, psi star is the conjugate, right. So, in this case the quantity psi star psi is known as the probability density. Okay.
यहाँ पे हम probability density जो जिसके ऊपर हम bombard कर रहे हैं उसकी कर रहे हैं, the nucleus,
हाँ,
not the beam of electron जो हम लोग उसकी कर रहे हैं.
नहीं, बेसिकली हम इस वक्त वही फाइंड करना चाह रहे हैं कि न्यूक्लियस का रीजन कहाँ तक है, ठीक है ना. ओके. So, if we want to find the probability to find the particle between the limits, let us say x1 and x2, then we can take the integral of these probabilities. So, we can write it in the form of a integral. And the total probability to find the particle must be one. So, this should be equal to 1, and this condition is known as the normalization condition. This is the normalization condition. So, therefore, any function of x which is f(x) can be evaluated. For this quantum mechanical system. So, the values that we measure for Fx are determined by the probability density, and the average value of Fx is determined by finding the contribution to the average for each. Uske baad we can find the average of this by using this formula, right. And these values, these average values are called quantum mechanical expectation values. इसमें परेशान नहीं होना, मैं सिर्फ वो छोटी छोटी इक्वेशंस इंट्रोड्यूस कर रही हूँ. वी आर नॉट गोइंग टू गो इनटू द डिटेल डेरिवेशन और समथिंग लाइक दैट. ओके, सो आई जस्ट वांट यू टू नो देम सो दैट जब ये आए तो आपको यू कैन अंडरस्टैंड इट. ठीक है. ओके, टेक अ फोटो. हो गया. ओके, सो ये थोड़ा सा सिर्फ एक वो पेज नंबर पीछे से जाके ना उसकी थोड़ी सी समरी लिख दी है मैंने. ठीक है. अगेन वो चैप्टर पूरा ना पढ़ के परेशान हो ना. ठीक है. हम सिर्फ उतना उतना लेंगे जितने हम यूज़ करेंगे उसको, उतना उतना मैं आपको साथ साथ बताती जाऊँगी. ठीक है. डोंट वरी अबाउट दैट. So, probability for the transition will be proportional to the quantity So, let us say this is equation 1, and in terms of charge this can be written as so you know we have a capital V and we have a small v. So, the capital V is the potential, the small v is the volume. So, let us choose the normalization constant such that F0 is equal to 1, then Q is equal to K1 minus Kf. And this is what does this represent? This represents the momentum change. The momentum change of the scattered electron. So, if we have, this is a figure in your book which is figure 3.3, and according to this figure we have a system where we have an electron that is bombarded on a nucleus, let us say here, okay, and then we define the electron let us say by R and the nucleus by R prime. So, this will be R minus R prime. Let us say this is an element dq and this is the electron. Okay.